Hello D Scott, welcome back to my channel. I'm recording this session for the second time because in my prior content, due to some technical glitch, my voice was not being recorded. I hope this time it gets recorded. Yeah, I think it's working as expected. So, yeah, today I wanted to talk about the optimization techniques. And if, let me ask you a question. Have you ever run a PySpark job and thought, why is it taking so long? In those cases, what you might be doing is increase the cluster size, or you may restart the job, but still you see the job running slowly. Today, I will show you why the PySpark jobs are actually slow in real projects, and we'll be using the same TPCH dataset. If you are a serious data engineering person, this video will save you hours of debugging and cloud cost. So let's get started. Let's go to the notebook. So I'm calling the source data to a temporary data frame like that is orders and line items. Now before that, I want to tell you one thing. Slow jobs are not usually because Spark is bad. Slow jobs are not fixed by just adding more nodes. Slow jobs happen because we write inefficient transformations. We don't understand shuffles. We join the data very blindly. Today we will break this down step by step. The very first one is the biggest myth is if the job is slow, increase the cluster size. In real projects, this often makes things worse. Do you know why? Because Spark is already distributed. If your logic is bad, you are distributing the bad logic faster. And for a quick understanding, let's use the same TPCH data with a large order, customers table, and line items table. This is very close to what we see in the enterprise systems. And let's load that into a sample data frame. And the both tables are large. What happens if I joined them carelessly? Right? Let's say this is my column, and I just want to show you the list of columns that we have here. And if you join this with the orders table with order key with an inner join, it took seconds, but still, see what is the record count that we have? It's huge. And also, if you see the query profile, there will be shuffling happening here and there. In this case, it's pretty decent, but in some cases there'll be load of mapping here and there, lot of jumpings happening. But even in this, what I would suggest is this looks like innocent, but behind the scenes, your Spark is redistributing millions of records. If you don't control shuffles properly, your job time explodes like something, right? So this is the number one reason why PySpark jobs are slow is shuffle. A shuffle means Spark has to move data across executors, write to disk, read again. This is extremely expensive. And the second reason which I want to tell is the bad joins. It's a second killer which will take a lot of time for your notebook to execute. Let's say if there is a many to many join, or if there is a joining without any understanding about the cardinality, then there is no point about what data you are going to get. You'll be getting a huge spike in the number of records that you have in the final table. This is very important. So if your join count suddenly increases, then it's a red flag. This is how the KPIs go wrong, dashboards lie, performance, goes for a top. So this is one thing which we need to clearly understand ourselves, beware about all this cardinality and other things. Why do you do this? Third thing is the data skew. another silent killer. This happens when one key has got too many records. One executor has or one executor does most of the work. So Spark looks busy, but only one task is completely suffering. For that beautiful, for that to explain beautifully, I would say let's use this command. So for the line items data frame, I'm doing a group by the order key. I'm asking it to get the count of it, which means one order will have multiple line items, right? This means one partition is overloaded. This is a data skewness. And also, the fourth thing that I wanted to let you know is unnecessary actions in your notebook or in your script. There's a big mistake that many of us do, like writing count, show, collect functions. This can be used repeatedly during your debugging, but not during your live runs. This will kill your time because every action triggers a full Spark job. Too many actions means too many jobs, which means a slow notebook, right? Now that you understand why jobs are slow, and in the next videos, I will try to explain you how to fix each problem properly, like how to reduce the shuffles, how to use a broadcast join, how to handle skew, when to repartition, how to read Spark UI like a pro. And if you have ever struggled with slow PySpark jobs, this optimization series will completely change how you work. Like the video if this helped, share it with your data engineering friends, and subscribe to DE Simplified for real world PySpark and Databricks content explained simply. I will see you in the next video. Until then, bye